You know, what makes a piece of code like truly great? It's usually not just the code itself, right? It's the story behind it. Today, we're going to dig into one of those stories from Gumroad. It's a tale of persistence, of really careful planning, all wrapped up in a single, beautiful pull request that solved a problem that had already stumped developers 3 separate times.
And it all kicks off with a really simple, very human problem. Just put yourself in the shoes of a Gumroad creator for a second. You want to do the right thing, you want to refund a customer, but the system just flat out says, nope, your balance is too low. So suddenly you're just stuck. Your customer's waiting, and what should be a simple 2-click interaction turns into this moment of total frustration. This isn't just a tech glitch, you know? It's a crack in the trust between a creator and their audience.
So here's how we're going to break this down. We're actually going to follow the structure of a perfect commit message. We'll start with the creator's dilemma. We'll dive into the 3 blocked attempts that came before. We'll look at the blueprint that finally led to success, see how the solution was actually built, and then wrap it all up with the perfect commit that brought it home.
All right, first up, the feat, or the feature. Now, on the surface, the goal sounds pretty simple. Just like creators automatically top up their balance with a credit card when they need to process a refund. But, as we're about to see, taking that simple idea and actually making it work was a huge technical challenge.
And this right here, this is the villain of our story, the insufficient balance error. This is the exact roadblock that this entire pull request was designed to just completely smash. It was a hard stop that left creators feeling totally powerless, forcing them to wait for new sales to come in just so they could handle basic customer service.
Now we get to the why part of the commit. See, this wasn't the first time someone tried to fix this. It was actually the 4th attempt. 3 previous pull requests had been submitted, and all of them were blocked. That history is so important. It really raised the stakes and meant that this next solution had to be absolutely 100% bulletproof.
Which, of course, leads us to the big question. Why did they fail? What were the hidden traps? What were the complexities that made this thing that seemed so straightforward, so tricky to get right? Because really, understanding these failures is the key to appreciating why the final success was so brilliant.
So, here's the postmortem. The first attempt? Just abandoned. The second one was, well, it was a mess. The user experience was bad, it was missing key features, and it broke a core database rule. It used foreign keys, which were a big no-no in this part of the codebase for flexibility reasons. And the third try? It was just incomplete. Split into 3 different pull requests, and it didn't have the required tests. The big takeaway here is that the failures weren't just about bad code. They were about process and completeness too.
So how do you succeed where 3 others have already failed? Well, you don't just jump in and start coding. You start with a plan. A really detailed, meticulous blueprint that learns from every single one of those past mistakes. And this was that plan. A success criteria that was basically a checklist born from failure. A single, comprehensive PR, no more splitting it up. A separate UI form to create a better experience. Full functionality to create, read, update, and delete cards. Strict adherence to that no foreign keys rule, and of course, complete tests and a video demo. This time around, there were going to be 0 shortcuts. And this part is just so cool. Before writing a single line of new code, the developer did something they called code-based cartography. They literally mapped out the existing refund system, studied payment patterns, and analyzed the entire architecture. It was like an intelligence-gathering mission to fully understand the terrain before launching the attack.
Okay, so with the blueprint in hand and the map of the codebase totally understood, it was finally time to build. The implementation was this really systematic, layer-by-layer process, making sure every single piece was solid before moving on to the next one. The whole solution was built across 5 different layers of the software stack. We're talking from the very deepest level, the database, all the way up to the pixels that the user actually sees and clicks on. Let's walk through them.
Starting at the foundation, the database, 2 new tables were built, one for the credit cards and another one to log every single transaction. And crucially, they were built without those foreign keys, perfectly following that strict rule from the success plan.
Next up, the models. These give structure to the data in the code. A balanced load model was created, and it had this really critical piece, a state machine. You can think of this as the brain of the whole operation. It precisely tracks every single transaction as it moves from pending to either successful or failed. Nothing ever gets lost.
Layer 3 is where all the business logic lives, and it's so neatly organized into these distinct services. You've got one service just for managing payment methods, another one that handles the Stripe charge itself, and a third one that runs in the background to handle the more complex stuff, like security checks. It's just a really clean, separated approach to a complicated process.
And now for the magic trick, the integration. The existing core refund code was really carefully modified. Now, when a creator tries to issue a refund and their balance is too low, the system automatically kicks off that new charge service. It just plugs the new feature seamlessly into the old workflow. Beautiful.
And finally, we get to the user interface, the part the creator actually sees and uses. A brand new React component, built with secure Stripe elements, created this dedicated section in the settings just for managing cards. With a clean interface and its own save button, it completely wiped out the user experience problems that killed the earlier attempts.
So after all of that planning, that mapping, and that careful building, we finally arrive at the last piece of the puzzle, the resolves. This is where the perfect commit message ties this entire journey together.
Just look at the clarity of this commit message. It starts with the feature type, a clear title, but that summary is everything. It explains not just what the code does, but why it matters. I mean, this is a masterclass in how developers should communicate.
And the scope of this thing? Almost 1,300 lines of new code. This was not a tiny fix. This was a substantial, complex feature, and it was all delivered in one single, comprehensive pull request. Exactly like the blueprint demanded.
All that work, all that learning from the mistakes of the past, it all led to this one moment. The problem that had haunted this code base for so long was finally, truly solved, and the proof is right there in the final line of that commit message. This, right here, for any developer listening, you know this is one of the most satisfying lines you can ever write. Resolves #1594. It's that magic command that tells GitHub, this issue, yeah, it's done. It formally connects the code to the problem, and it closes a chapter that had been open for way, way too long. Mission accomplished.
So this whole story leaves us with a question, doesn't it? What really makes a code contribution great? Is it just the technical skill, or is it the meticulous planning, the persistence to learn from failure, and that crystal clear communication that proves you didn't just solve a problem, you actually truly understood it?